All right, welcome everyone. Okay, this particular video is we are solving a system of equations by using elimination. This is the most commonly used method that we do, and honestly, it's the one I go to a lot. Some students find it easier, so let's go ahead and begin. Okay, what you're looking at here is this is going to be some definition here. So what you need to know is that elimination involves the addition or subtraction of two equations with the purpose of eliminating one of the variables. So basically you're adding, I don't usually do subtraction, but you're adding two equations together because one of them is going to fall out. And if they don't automatically do it, then you do whatever you need to do to fix it. Again, this should be review because you did cover this in Algebra 1. So let's go on, okay? And so I kind of already have this done because as it turns out, I made the video and my microphone wasn't plugged in. So what you're seeing here is what you want to do is you want to make sure X and Y are on the same side, so you want it in standard form. And so what I did here is I just subtracted 5y from both sides here. So that's why I have 3x minus 5y equals 12. And then once I do that, I just recopy the second one. So 2x plus 5y equals 7. Add them together. You're going to get 5x. This cancels or eliminates because it goes to 0. And then this is going to be 19. Okay? And then when you divide both sides by 5, you get x is 19/5. From there, you remember, you take that answer and you substitute it back into one of the two equations. I chose to do the first one. I don't know why. There's no rhyme or reason. That's just what I chose to do. Okay, so I got 3 times 19/5 equals 5y plus 12. I just used my graphing calculator. If you're on a TI, I did 3 times parentheses, 19 divided by 5, close my parentheses, and then hit math, and then hit enter twice. If you're on a Casio, just use your fraction key. Okay, so I ended up with 57/5 equals 5y plus 12. I subtract 12 from both sides. Again, use your calculator and hit math, enter, enter if you're on a TI. And then it came back to me with a negative 3/5. Then you can either divide by 5 or I multiplied both sides by the reciprocal, which is 1 over 5. When I do that, I get a negative 3 over 25 equals y. So then my ordered pair was 19/5, comma, negative 3 25ths. Okay? Feel free to pause and replay as much as you need. Okay? Now, this one, what you want to do is, if you have two variables that are exactly the same but opposite, that's what you want. And if that happens, you just add them together and one of the variables will fall out. If that doesn't happen, then you're going to have to fix it. But this case, it's going to happen. So notice that the x terms are opposite coefficients. So when you add them together, you're going to get, this goes to 0. You're going to get negative 6y equals 24. Divide both sides by negative 6, you get y equals negative 4. Then once you do that, substitute that back into one of the two equations. I chose the first one. So I have negative 8x plus 3 times negative 4 equals 12. Negative 8x minus 12 equals 12. I add 12 to both sides. Then I divide through by a negative 8, so x is negative 3. So my answer is negative 3, negative 4. Okay? Now, here it's the same thing, but you want to make sure it's in standard form, so you want to do some moving. So what I did is I left the first equation as it was, but the second equation I moved the x to the other side. When I do that, I get x minus 5y equals negative 10. When you add the two together, you get 5x. This goes to 0, and then this becomes negative 5. So x is negative 1. Okay? And then you're going to substitute this back into one of the two equations. I chose the second one. So you have negative 5y equals negative 1 minus 10. Well, the opposite of negative 1 is positive 1. That's what negative x means. It's the opposite of x. So I'm going to have negative 5y equals negative 9. Divide both sides by negative 5. Y is 9/5. So negative 1, 9/5 is my ordered pair. And when you write them, you put the letters in alphabetical order. That's what we generally do. Okay? Now here, it's not as simple as just adding. We have to change the problem in order to make it work. So we had 3x minus 4y equals 2. I'm reading it so that you can copy it down correctly. And then 3x plus 2y equals 26. I'm going to multiply the second one by negative 1 because that will cause the x's to fall out. And then here's where I added them, and they do, where after I changed all the signs. And then you end up with a negative 6y equals negative 24. Divide by negative 6, y is 4. Then I substitute that back into looks like I did the first one. So 3x minus 4 times 4 equals 2. So 3x minus 16 equals 2. I add 16 to both sides. I get 3x equals 18. Divide both sides by 3, so x is 6. So my ordered pair is 6, 4. On this one, I chose to multiply the second equation by -1. And then because the 6y's were exactly the same, but there was no sign difference. So when I do that, I recopied the first one, which is x plus 6y equals 13. And then I changed the signs of everything on the second line. So that's 2x minus 6y equals 8. When you add these together, that's 3x. This goes to 0 equals 21. Divide both sides by 3, and you get x equals 7. Then I took that, substituted it back into the first one, because it seemed easier. So I have 7 plus 6y equals 13. Subtract 7 from both sides. I get 6y equals 6, so y equals 1. So your ordered pair is 7, 1. Okay? Again, this should just seem like review for you. Now, on this one, you're going to have to make some changes. It's not automatically going to fall out. So, number 5, it's actually 3x minus 3y equals 21. And the second equation is 8x plus 6y equals negative 14. I chose to get rid of y because it seemed like the least amount of work. So I multiplied the whole first one by 2. So that's how I got 6x minus 6y equals 42. Then when I add the two equations together, the y's fall out. So I end up with 14x equals 28. Divide both sides by 14, x is 2. Then I take that x, substitute it back into one of the two equations. It looks like I chose the first one. And so I did 3 times 2 minus 3y equals 21. So 6 minus 3y equals 21. Subtract 6 because it's already positive. So I get negative 3y equals 15. Divide both sides by negative 3. Y is negative 5. So my ordered pair is 2, negative 5. Now going back up, this one you have 3y equals negative 2x plus 17. And then 3x plus 5y equals 27. I'm going to move the 2x to the other side so x and y are on the same side. So I end up with 2x plus 3y equals 17. I decide to get rid of x, but I have to multiply both equations to do that. So I multiplied the first one by positive 3, the second one by negative 2. You could just as easily done the first one by negative 3, the second one by positive 2. When I do that, I end up with 6x plus 9y equals 51, and then negative 6x minus 10y equals negative 54. You end up with negative y equals negative 3. Divide by negative 1 or multiply by negative 1, and you get y equals 3. Then what you do is you substitute, remember, the y in one of the two equations. I chose the first one. So that gave me 3 times 3 equals negative 2x plus 17. So that becomes 9. I subtract 17 from both sides. I don't want to move x. It's already over there. Okay, and then I end up with negative 8 equals negative 2x. Divide both sides by negative 2. X is 4. So your ordered pair is 4, 3. Okay, again, please pause as much as you need to or rewind if you need to see it again. Okay, here are actually our last two. So this one is 7x plus 2y equals 26, and then this is 10x minus 5y equals negative 10. I chose to get rid of y because one of them was positive, one of them was negative, even though I had to do work to both. So when I do that, I'm multiplying the first one by 5, which gave me 35x plus 10y equals 130. And I'm multiplying the second one by 2. So that's 20x minus 10y equals negative 20. When you add them together, the y's fall out, and I actually end up with 55x equals 110. Divide both sides by 55, x equals 2. A lot of work, and you get that little bitty number. So then once I did that, I replaced the x in this equation, which is the second one, with 2. So I have 20 minus 5y equals negative 10. Subtract 20 from both sides because 20 is positive. You're going to get negative 5y equals negative 30. Divide both sides by negative 5, so y is 6. Okay? And then the last one, okay, I'm going to move the 9x to the other side. So I had negative 9x plus 5y equals negative 8. And then I recopied the second one, which is negative 20x plus 10y equals negative 10. I decided to get rid of y because it only took one step to do it. So I multiplied through the whole first equation by -2. I got 18x minus 10y equals 16. Recopied the second one, -20x plus 10y equals -10. Add the two together, you end up with -2x equals 6. Divide both sides by the -2, you get x equals -3. Then I decided to take the first one and substitute the x back in. So I have 5y equals 9 times -3 minus 8. So you have 5y equals -27 minus 8. Take the difference, 5y equals -35. Divide both sides by 5, you get y equals -7. So your ordered pair here is -3, -7. Okay. Again, it's just a lot of the same thing over and over. So hopefully that helped, gave you a lot of examples here. So I'm sure it probably helped. Okay, this next 2 pages, guys, is your homework. So that's what you need to be working on. So just make sure that gets done. So thank you, and I will see you on the next video.